All right, so we are going to be doing types of reactions, and there's 5 types of reactions we're going to do. Combination synthesis reactions, they're kind of basically the same name. Decomposition, single replacement, also sometimes known as single displacement, depending on where you're looking online, and double replacement, also known sometimes as double displacement, um, and then combustion. So these are the 5 types of reactions we're going to go over here. Okay, so the first type of reaction is the combination synthesis reaction. This is the idea when 2 or more substances react to form a single substance. Here would be an example. Sulfur, one thing combines with oxygen. So we have 2 single elements and they combine, or 2 smaller things which combine to make one larger thing. That's the big thing with the combination synthesis reaction. For this class is going to be 2 small things make one big thing. Okay, so there is a general reaction formula. You'll see these in your notes. Sorry, I saw liquid gas. So A plus B makes AB. So small thing 1 plus small thing 2 make a larger thing that's the combination of the 2 together. All right, so let's practice some. Okay, we're going to do some examples. We're going to have to combine them, and then we're going to have to balance them. So this is where we're doing a couple of different things. So we have to look at this, and we have to remember, okay, aluminum is 3 plus, oxygen is 2 minus. So the first thing we have to do is our crisscross. So that means these are going to make Al2O3. Okay, so there's our formula. Aluminum plus oxygen makes aluminum oxide. Now we have to balance it. So we have Al and we have O, and on this side we have 1 and 2. On this side we have 2 and 3. So we're balancing. Let's fix the aluminum first. We have 2 aluminum. Easy fix. Put that there. Now we have an odd number of oxygen on one side and an even number on the other. Remember, if you had odd and even, you double everything and rebalance. So this is going to, we're going to erase the 2. The 2 is going to double 204. Going to double this. So there's a 2 there. So we have 4 aluminum, 6 oxygen, 4 aluminum. And so to get 6 oxygen, we put a 3 there. So now 3 times 2 is 6. So that's balanced. Next, copper plus sulfur. We're going to make copper 2. You kind of have to tell you that if it's a copper. So this is going to be a Cu2 plus. And then we have S2 minus. They're going to combine together to make CuS, so they cancel each other out. This one we can look. We have 1 copper, 1 sulfur, 1 copper, 1 sulfur. So it is balanced. We don't do anything to it. Okay, again, this is our A plus our B to make AB. The 2 things combine together to make one larger molecule. Okay, here's our fairly common one. We have oxygen and hydrogen. This is one you just got to remember that it's going to make water. We have to balance it. There's 2 hydrogen over here, but there's 2 oxygen. So we put a 2 there. That gives us 2 oxygen. Now we have 4 hydrogen. Put a 2 there, and it's balanced. I've already done this as an example. That's why I'm just rushing through this one. Okay. Don't forget, don't bring subscripts across unless they're attached. And if you have to deal with polyatomics to do that, you cannot use halves as coefficients. Sorry, that should have been deleted. All right, so that is synthesis. A plus B makes AB. All right? All right. Next, decomposition. Decomposition is when a single compound is broken down into 2 or more simpler products. Okay, so in this case, there's a couple different versions of this. Basically, this is the opposite of synthesis. So here we have a simple or complicated thing, magnesium combined with phosphorus, so magnesium phosphide, and we break it apart into magnesium and phosphorus. Okay, it can get a little bit more complicated. Like here we have calcium carbonate. Calcium carbonate will actually break into calcium oxide and carbon dioxide. The complex ones, we're never going to ask you to predict these for this class. Those ones are a little bit harder, but you should be able to do the simple ones. It still works out really straightforward. So the synthesis was A plus B. The decomposition is going to be, surprise, surprise, AB turns into A plus B. So basically big into smaller compounds. All right? So let's try some of these. Okay, so first one, water. You can break water back down into H2 plus O2, because remember, you can't use, if it's one of the 7, you got some five, so it's H2 and O2. We have to balance it. I am just cheating to rush through this because you should be able to. It's the same thing we've already done with simplification. Here we have mercury oxide. Clearly, this is mercury 2 oxide. So mercury, when it's elemental mercury, is just Hg. But oxygen, you can't just write O. It's never just O. It's one of the diatomics, so it's going to be O2, which means, okay, we do have to balance it because we have Hg and O. On this side, we have one of each. On this side, we have 1 and we have 2. So we've got to fix the oxygen. So we put a 2 there. And we have 2 Hg, 2 O2. So the O is balanced. We need to fix the Hg. So we add some more mercury. Now it's balanced. Okay. Next up, we have, this is going to be silver 1 oxide. Silver 1 oxide is breaking apart. So this is our A, our B. We're going to make them separate. So we have Ag. And again, oxygen has to be O2. Okay, and then once again, we balance and we just set it up to count AgO, 2 Ags there, 1 O, and then 1 1. We need more Ag, or sorry, 1 2. So we have 2 Ags, we need 2 Ags, we put a 2 there, that fixes that. However, 2 Os, we have to put that there. Now we have 2 Os, but we have 4 Ags. So we replace the 2 with a 4. And now we are balanced. So that is decomp. Decomp is just a larger compound breaks into 2 or more smaller compounds. Again, this is probably, of all of these, this is the one I'm least likely to require you to predict because it's just a little bit hard. It's a little bit too hard. You kind of have to know a little more chemistry than we're doing. Okay. All right. On to the next one. Single replacement or displacement reactions. Atoms of an element replace the atoms of a second element in a compound. Okay, so this is the one I call the breakup. Okay. So we have right here a lovely couple, copper sulfate. Okay, they're together, they're all bonded, they're happy, but along comes sexy, sexy iron. And iron's like, I am bigger, I am stronger, and I am more reactive. And sulfate's like, ooh, you're so sexy. And so that was really funny. I can't believe I just said that, or ridiculous. I can't believe I just said that. But so in a single replacement, what happens is the lone element, kicks out one of the elements. So in this case, iron is a metal, so it's going to replace the metal. So iron kicks out the copper. So now we have iron 2 sulfate, and the poor copper is off on its lonesome. It's so alone and by itself. Okay. So the general equation for these is A is the individual. So if it is a metal or a cation, it's going to replace the other cation, and the new metal will be off by itself. If it's a negative, so like if it's chlorine gas or something like that, if it is an anion, then it will replace the anion in the equation. But the key thing is you have one element by itself, and it's going to, and then you have a combo. That's part of how you can recognize this as single replacement. You have a single element and you have a compound, and the single element will replace one member of the compound. So let's try some of these out. Okay, so zinc reacting with sulfuric acid. Okay, so zinc, we remember zinc has a positive ion. It's Zn2 plus. Okay, and you have sulfuric acid, so H is the positive cation, so that means the zinc is going to replace it. So this is where we got to do our naming stuff. Hydrogen is a +1, sulfate is a 2 minus, well, there's two of those right here. So the zinc is going to combine with the SO4, because the zinc is going to kick out the hydrogen. And the hydrogen is going to be all by itself, but you can't forget, when hydrogen is by itself, it's H2, so it is H2. Okay, so it's a replacement. Now we look, one zinc, two hydrogen, one sulfate, so it is balanced. Okay, next one, we have K, potassium. Remember, potassium is a positive. We have OH. Well, what's going on? Well, we have water. Here's the thing to remember about water. Think about water as if it was HOH. So it's a hydrogen combined with a hydroxide, because that's the same thing, right? So in this case, the K is positive. It's going to kick out one of the hydrogens. So you have KOH, potassium hydroxide, right? And then you have the hydrogen off by itself. And once again, it's a diatomic, so it's got to be H2. So there's the equation, but it is definitely not balanced, right? Think about this as HOH. So we have K, OH, and H. There's one K, one OH, one H, one K, one OH, two H's. So we have to double this. So now we have two H's, but we have two OH's. We have to put a 2 there. Now we have two K's. So put a 2 there. And we look, can we simplify this? I'm going to write it neater. 2, 2, 2, 1, can't simplify, so that is the balanced equation. Okay, but again, the potassium is a positive and it replaces one of the hydrogens, which is also a positive. So you know it's single replacement. Okay, right here, tin. We're going to make our lives easier, and we're going to say this is tin 4 plus. Tin is positive, so the sodium is positive, so the tin is going to replace the sodium. So we had SN, and we said it's 4 plus, so NO3, 4. And then the sodium is the boyfriend that got kicked out, so the sodium is by itself, Na, and it is not one of the 7, so you just write Na. I get a lot of kids who occasionally will put a 2 there. No. The 2 is only if it's one of the 7 diatomics, so no 2. However, now we have to balance this bad boy. So let's balance it. We have tin, we have Na, and we have NO3, and we can treat it as one. NO3 is one thing because there's an NO3 there and an NO3 there. So on this side of the equation, we have 1, 1, and 1. On this side, we have 1, 1 Na, and 4 NO3s. So we got to fix the NO3s. So we put a 4 there, 4 NO3s. But oh look, now we have 4 of the NAs. Okay, well how do we have 4 NAs over here? We put a 4, and it's balanced. Okay, I'm rolling through the balancing because just to kind of help you see how they go. If you want more balancing, we'll review that more. The key thing is for single replacement, you have one element by itself, okay, and then you have a compound, and then the element will replace one member, and you'll get a new compound and a new lone element by itself. Okay. Let's actually try color coding that. So like if we're looking at this, We have A, we have B, we have C, and it's going to make A, C plus B. So in this case, there's a B, there's a B, there's a B, there's a B, there's the B, there's the B, there's A, there's A, 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 whoops. Oh no, C, sorry, my bad. There's our C, whoops, wrong color. There's our C, 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 C. So I hope the color coding didn't throw it off so much. One element by itself replacing another one. All right. Double replacement. Double replacement, double displacement. This is a more complicated one. Okay, double replacement involves an exchange of positive ions. So look, here we have silver, here we have potassium. Those are positives. They are going to switch places. Okay, so we end up getting the Ag with a Cl and the NaO3 or NO3 with the K. Okay, this is our general. We say this looks though super crazy. So we have another way of saying it. The other way we say it is we have outside, outside, inside, inside. So when you look at this, look, what's on the outside? Outside, silver, chloride, outside, outside. Hey, look, they make that. And then the inside, K, NO3, inside, inside, makes that. It's a double displacement, double replacement. Okay, so let's try this. Okay, we'll start with, you know that it's double displacement as well because we have two compounds. Anytime you have two compounds, for the purpose of this class, we're going to consider it a double replacement. So, start with this. Outside, outside. So Na, which is a +1, and SO4, which is a 2-. So we're going to have Na2 SO4. So there's our outside, outside. And then we do inside, inside. H and OH is going to make HOH, also known as water. So there's our inside, inside. But now we still need to balance this. We have Na, SO4, H, OH. There's 1, 1, 2, and 1. And over here we have 2, 1, 1, and 1. So we need 2 H's over here. So we put a 2 there. Gives us 2 H's and 2 OH's. We have the Na, we need 2 Na, we put a 2 there, 2 Na, 2 OH's, and that's all balanced out. Next one, outside, outside, Ba with CO3. Ba is a 2+, CO3 is a 2-, so it's going to make Ba CO3. There's our outside, outside. Inside, inside, we have K, we have Cl. K is a +1, Cl is a -1, so it makes KCl. So there's outside, outside, inside, inside. Then we have to balance. If you look at this, there's 2 Cl's, 2 K's, so I have to put a 2 right there. Okay, again, outside, outside, FeCl. All right, we have to look. Fe is with the sulfide. Sulfide is 2-, so that means this has to be Fe 2+. Chlorine is a -1, so it's going to be the outside, outside. It's going to be Fe Cl2, iron 2 chloride. There's our outside, outside. And then inside, inside, we have H and we have S. H is a +1, sulfide is a 2-. So we get H2S, so hydrosulfuric acid. Okay. Then we have to balance. We have Fe, we have S, H, Cl. Over here we have 1, 1, 1, 1. Here we have 1, 1, 2, 2. So we need to get a 2, 2, 2, and it's balanced. So that is double displacement or double replacement. Outside, outside, inside, inside. Finally, combustion. Combustion is a little bit weirder. Anytime you have a carbon compound react with oxygen, it's a combustion reaction. And it always makes two things. It makes CO2 and it makes water. So the general equation is this. This is C, anything we have a C and an H, and the X and Y means, it could be C2, H8, H6, it could be C2, H4, it could be C8, H16. There's lots of different kind of combinations. It just has to have a carbon and a hydrogen compound that's made of carbon and hydrogen in some amount. And then it's always going to combine with oxygen for a combustion. And they will always make CO2 and always make H2O. So the stuff with combustion reaction, predicting the products is really easy because it's always these two things. The bigger part is you have to spend a little bit more time actually balancing it. So let's try some of these. C6, H6 plus O2, we know it's going to make CO2 plus H2O. So we just have to balance it. We have 6, 6, and 2, and 1, 2, and 3. That's the other nice thing. They're always 1, 2, and 3. So always do the carbon first. So we throw a 6 right there. 6, but now we have 12, 13 oxygen. Remember, do oxygen last. So we have 6 hydrogen, so we need 6 on this side. We need 6. We throw a 3 right there. That gives us our 6 hydrogen, but then now we have 12 plus 3, 15 oxygen. So remember, the rule is when you have an even number on one side and an odd number on the other, you double everything and rebalance. So we'll put a 2 here. The 6 will turn into a 12. The 3 will turn into a 6. Now we'll have 12, 12, 30, 12, 12. And to get to the 30 here, the 15 goes right here. Now we have 30. And you look like, that's crazy. That's so big. But can you simplify this? No. 2, 15, 12, and 6. It cannot be simplified. So that is it. It's a big, big, gnarly one with lots of numbers. Okay. So one more. So again, we have our carbon and hydrogen compound reacting with oxygen. So it's going to make CO2 plus H2O. We just have to balance it. So CHO, this 8, 10, and 2, and then 1, 2, and 3. Carbon first. So we have 8 carbon here, and we want 8 carbon over here, so we throw an 8 right there. So then 8 times 2 is 16, and that's in the wrong spot. Sorry about that. 8 times 2 is 16 oxygen, plus another one there is 17 oxygen. Now we have 10 hydrogen here, so we need 10 hydrogen here, so we put the 5 there. Now we have 16 oxygen plus 5 oxygen. 16 plus 5 is 21, blackjack. So once again, odd number, even number, so we have to double everything and simplify. We put a 2 there. This goes to 16. This goes to 10, 16, 20, 42, 16, 20, and to get to 42, we take the 21. Put it right there, 42. Again, that looks huge and ridiculous, but you have an odd number. You cannot simplify this, so that actually is what you have to do. Okay, so that's combustion. Again, combustion is easy because it always ends with the same two things. So we have synthesis. Synthesis is A plus B makes AB. Two small things make a big thing. We have decomp. That's AB turns into A plus B. One big thing turns into two small things. We have single replacement, where we have a single element by itself and a compound, and the single element will replace one of the parts of the compound to make a new compound and a new single element. And then finally, we have double replacement. Double replacement, this is where you have two compounds and you have outside, outside, and you have inside, inside, two compounds, outside, outside, two new compounds. And then finally, I just realized, let's make sure, combustion. I'm sorry about my spelling. Combustion is a carbon hydrogen compound combines with oxygen to make carbon dioxide and water. So those are the different types of reactions that you need to know and examples.